Hi, I'm Cindy from Streamscape. I'd like to welcome you to our Getting Started video series on Streamscape TV. In this video, I'll show you how easy it is to create a local data engine using the TruView application workbench. A local data engine is fully functioning and self-contained. Users can configure, develop, and test locally and then deploy it into an existing sysplex. When it is pushed into the cloud, it can work as a standalone application or interact with other data engines as needed. So what we're doing in this video is creating that local data engine or local node. Let's get started. I'm here in the TruView application workbench. Every node must have a unique deployment descriptor. This is a configuration object that allows us to uniquely identify a node. I have a wizard that I can work with here. And for the most part, I can keep all the defaults, but I did want to point out a few things. Referral domain identifies what domain or cluster this node is going to belong to. Ideally, you would have identified a domain on your local machine or on the cloud where this node is going to live. In my case, this is odin.com, but you could leave that as domain 1, the default, if you wanted to. I will leave the security principal as admin, and I'm going to give it a password. And then the last thing I need to look at is the node name. Let me call it a sample node. Just a little note on these naming conventions. If you're a Java developer and develop with application servers or J2EE technologies, you'll notice that the notion of referral domain, security principal, and security credentials map to JNDI concepts. This isn't by accident. This is because all of this maps to a standard security framework that's used across industries. You can use this to connect up to backends which are managed and secured through LDAP, through Active Directory. That's why these terms have made it into here. So let me finish up here. In our case, we're going to want to put this in our install directory. In our install directory, we have a directory called nodes. I'm going to create a new directory and I'm going to call it sample node. It's giving me a name, stdeployed.jar. All the artifacts are named that. They are purposely obfuscated at the name level. You need to use our tools to view or edit descriptor contents. The deployment descriptor is meant to be secure and only accessible by the person who authored it. So now if we right-click on local nodes and choose Create Node, we can navigate to that deployment descriptor we just created. It has filled out the information it got from the descriptor. Now the port name says default. If you decide you're going to leave it as default, as we would suggest you do, the system's going to assign a default port, which is going to be used for administrative purposes. You could, by looking back here later, go ahead and reuse this port and launch these nodes independently outside of the workbench, and if you did, the workbench would automatically find them later. So let me choose next. Unless you have a really great reason to configure this, you can leave it, but you might have a reason such as giving the node more memory at startup. By default, we don't specify how much memory a node will use. We allow Java to decide that. There's pop-up help here which will show you an example of how to change the memory allocation. This is an in-memory data grid, so it's very possible that you will need to give it a little more memory, or at the very least curb how much memory the system uses. By default, Java will use as much memory that's available to the system, so don't be surprised if you run a very large test and the node eats the machine. This is as intended. It's a consequence that teaches us about memory management. At the end of the day, it's just another Java process, so we give it the tools and capabilities to curb and control the capabilities of the process. It'll run anywhere, and even in container frameworks such as Docker, etc., completely transparently. So here I'm just going to choose Finish. So here is our sample node. So that we can see all the initialization take place and get a better look at what tracing is available to us, I'm going to turn that on right now. When I right-click, I can choose View Error Log, and that will bring up my log miner. So now I have the log miner pointing to sample node. If I choose Live Log, we can see the live log progress as we start the sample node. So I'm going to right-click here and start the node. Now in LogMiner, we can see all the entries from the initialization and the startup of the node. If you're familiar with operating system design, like Unix or Linux design, we follow a very similar theory. There are 4 run levels in order for it to complete its initialization, that it has to go through all of them. By level 4, it makes it available for use. There's more detailed information on our wiki if you'd like it. So you can see that we made it to runtime level 4 and we're okay. The container was started. You would see red here if there were error messages. One of the most problematic issues starting a node is choosing a port that's already in use by another product. Lots of red will display in the log and you'll see that the node failed to start. If you check the log and see what happened, and for this problem either shut down what's using the port or change the port that the node is using, you should be just fine. Now let's have a quick look at what was actually created on disk. I have my sample node directory, and right here, if we have a look, we have stdeploy.jar, that's my deployment descriptor. We have tnode.log, that is the log file that we're actually looking at live via LogMiner in the workbench. And then we have tnode.traces. Tnode.traces contains all the information about trace settings for this particular engine. They're all accessible via the workbench. It provides tracing down to the class level, high-level tracing. I'd even say a bit more sophisticated and versatile than, let's say, log4j. Traces can be redirected to applications or other programs and allow you to do very detailed discovery. Now the directories that have been created, the 3 of them, you can see they start with the dot. They're system names and they're really not intended for human interaction. But just so you know, DS cache is our holding place to persist data space information. HT cache holds all our web HTTP stuff, and then TF cache is our internal repository. Okay, back to the workbench. So we've started it, we've taken a look at live logging, we've taken a look at all the directories that were created, and now we can connect up to the node. You can see here we've successfully connected, and we have all the resources available. We have client connections, global objects, runtime objects, data spaces, security. Everything is all here and available. To recap, we have created a deployment descriptor, created a local data engine, started that engine, connected to it, and checked out all those logs. This is Cindy from Streamscape, and thank you for watching Streamscape TV.